Acids and bases, part 4, where we'll be looking at hydrolysis, indicators, and titrations. Hydrolysis is a reaction of a salt ion with a water. There is no hydrolysis when dealing with a strong acid or base. Take this one for example. You have HCl and NaOH. Na is +1 and Cl is -1. Thus, it neutralizes, so there is no hydrolysis. There's an example of a weak salt, and here is an example that you need to by heart. This is literally in most of the exam questions and most common type. Here are some steps that I thought would be helpful. So, you first need to identify what it comes from. So, the NH4, so you have NH3, and the Cl comes from HCl. Then you focus on the weak, being the NH3. Then you just do the equation and make sure you have water in the equation because it is hydrolysis, meaning water. We will now move on to indicators. Indicators are usually an application question that we get during exams or tests. We have three different types. If it's a strong acid and base or a weak acid and base, you use this. This is neutralization. In a base, it turns blue, and in acid, it turns yellow. If there's a strong acid and a weak base, we use this. In a base, it turns orange, and in acid, it turns red. The last one we use when it's a weak acid and a strong base. In a base, it's colorless, and in acid, it's pink. However, we must not forget about our litmus paper. In an acid, blue litmus paper turns red, and in a base, red litmus paper turns blue. Titrations are a technique for acids and bases. It is basically when you reach your endpoint meaning neutralization. This happens in a standard solution meaning your concentration is known. Let's look at an example. NaOH plus HCl will give you NaCl plus H2O. You have your volume and concentration of NaOH, and you only have your volume of hydrochloric acid. Your concentration is unknown. When you see this, you should know that you are able to work out your number of moles. So you do. When you put in the formula, your number of moles will be 0,0025 moles. 25 times 10 to the -3 because they have given you your volume in centimeters cubed. You need it in decimeters cubed, thus you times by 10 to the -3 or just divide by 1000. NaOH and HCl have a ratio of 1:1 because the number in front here is an invisible 1. Thus, you can use the same number of moles to work out the concentration. So you have your volume, you have your number of moles, and now you solve for concentration, which is 0,125. However, there is a special titration equation, which you can use here. It's Na over Nb equals Cav Cbvb, which this number here is your balancing number. Like I said, there's an invisible 1 here, so it's 1:1. Then you just work out your concentration of your acid, volume of your acid, concentration of your base, volume of your base. You're still solving for your concentration of your acid. This involves many steps, but you still get the same answer as this.